In this video, I'm going to give the solution of 2008 Step 3 Question 8. So the first question is letting us we have the series S where the coefficients satisfy a recurrence relation of the form AR plus 1 plus PAR equals 0. And it asks us to write down the value of P. From this series, you can very easily see that S is actually a series that which coefficients is actually a geometric progression. So we can see that A1 is equal to let me see, this is x to the 1, so A1 is 1 over 3 and A2 is 1 over 6 and A3 is 1 over 12. So we can see that AR plus 1 is actually equal to 1 over 2 AR. So because this is equal to 1 over 2 times 1 over 3, and this is equal to 1 over 2 squared times 1 over 3. So we can have our p-value as negative 1 over 2. And the second question asks us, by considering 1 plus px bracketed as, find an expression for the sum to infinity of s, assume it exists. So by considering 1 minus 1 over 2x s, by considering this term, we need to find the expression for the sum to infinity of s. So let me see. So let's see what is the result of this expression. So we have this as 1 minus 1 over 2x times 1 over 3x plus 1 over 6x squared plus 1 over 12x cubed plus all the way to infinity. So this is equal to 1 over 3x plus 1 over 6x squared plus 1 over 12x cubed plus and by multiplying negative 1 over 2x to all the terms in S, we would end up with, we'll have negative 1 over 6x squared minus 1 over 12 x cubed minus 1 over 24 x to the 4th minus all the way to infinity. So you need to observe that all the terms that is comprised behind this that is circled in this I'd say blue circle are all cancelled. So this 1 minus 1 over 2x times s is actually equal to 1 over 3x. So we would have so I should mark this as s infinity because it is the sum to infinity of s. S infinity is equal to 1 over 3x. So we will have our s infinity equals 1 over 3x over 1 minus 1 over 2x, which is literally equal to 2x over 3 times 2 minus x. Okay, so the second question is saying that find also an expression for the sum of the first n plus 1 terms of s. So we are asked to find the first n plus 1 terms of s. So now our s we need to find Sm plus 1, which is simply 1 over 3x plus 1 over 6x squared plus dot 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 plus all the way to ar plus 1x to the r plus 1. So this is the sum that we are going to calculate. So you need to recognize that it is actually a geometric progression. So this is actually equal to 1 over 3x plus 1 over 3x times 1 over 2x plus 1 over 3x times 1 over 2x squared plus all the way. So we have r plus 1 total terms comprised in this is m plus 1. So we have total m plus 1 term that is comprised in this series. So the last term is just 1 over 3x 1 over 2x to the nth. And this is not very difficult. By extracting 1 over 3x in front of this series, and we are left with 1 plus 1 over 2x plus dot 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 all the way to 1 over 2x to the nth term. Sorry, to the nth. I should end this bracket using my blue marker. And this is not very difficult now, because this equals 1 over 3x times 1 minus x over 2 and plus 1 over 1 minus x over 2. So I think this is the result of our Sm plus 1. So the second question is provided another series named as T, and it says the coefficients in the series T satisfy a recurrence relation of the form a r plus 2 plus p a r plus 1 plus q a r equals 0. So finding, sorry, I think maybe I missed something. Oh no, I didn't miss anything. So the coefficients in the series satisfy a recurrence relation of the form a r plus 2 plus p a r plus 1 plus q a r equals 0. So find an expression for the sum to infinity of t. Assume it exists, because I'm too lazy to write these three vocabularies. So now we want to find is the sum to infinity of t. So we want to find t infinity. And as I said in the previous videos, a step question usually uses the method or the result that you have derived before. So in this question, in the second question, you may use the method that is suggested in the first question. So the first question, find the sum of infinity by considering this term. So maybe we can consider we can have some terms to consider because we have we may have some terms to consider as well, and it definitely relates our recurrence relation. So because don't you think the multiplier in front of s is very similar to the recurrence relation that has been suggested? So now we want to find our recurrence relation in the first place. So what is our recurrence relation? From the series, we can have, oh, I'm sorry. I deleted something I shouldn't have deleted. Okay, so from the series, we can have our a0 equals 2, a1 equals 8, a2 equals 18, a3 equals 37. Yes, I believe it is correct. So now all we need to do is just to substitute all of those a's into our recurrence relation and find two parameters p and q. So a0 is we will have 18 plus 8p plus 2q equals 0, and 37 plus 18p plus 8q is equal to 0. And I'm too lazy to work out those simultaneous equations now, and I believe it is not the point that we are that this video is emphasizing on. So I will just give the value of p and q, which are p equals -5/2 and q equals 1. Okay, so our recurrence relation is just ar plus 2 plus, oh, I'm sorry, ar plus 2 minus 5/2 ar plus 1 plus ar equals 0. So this is our recurrence relation, and so now the term that we want to consider is just 1 minus 5/2x plus x squared t infinity. So I believe by considering this term, we can have some juicy results that we would like to see. So this actually equals 1 minus 5/2x plus x squared times 2 plus 8x plus 18 x squared plus 37x cubed plus all the way to infinity. So this equals 2 plus 8x plus 18x squared plus 37 x to the 3 oh yes, x to the 3 plus and here we have negative 5x, and we maybe I should use another color to distinguish between all the terms. So by multiplying this two, we have negative 5x. Well, by multiplying those two, we will have let me see. So this equals negative 20x squared plus, I'm sorry, it's minus 45x to the x cubed minus something x to the 4th. I don't know what x to the 4th. So now we have let me see. I should use purple. So this is 2x squared plus 8x to the 3 plus 18x to the 4. Never mind. The point is that this recurrence relation actually exists in this computation. So I should use this color. So so those terms it merged and gets us 0, and those terms merged gets us 0, and all of those terms merged gets us 0, and we have 2 plus 3x right here. So our result is quite clear. 1 minus 5 over 2x plus x squared t infinity is actually equal to 2 plus 3x. And now t infinity is equal to 2 plus 3x over 1 minus 5 over 2x plus x squared, which equals, I should multiply 2 on both numerator and denominator to make this expression nicer, which is 4 plus 6x over 2 minus 5x plus 2x squared. Okay, so this is our t infinity, and the next question is asking us to by expressing t in partial fractions or otherwise find an expression for the sum of the first n plus 1 terms of t. So our goal is to find an expression for the sum of the first n plus 1 terms of t. So this is our goal, and the suggested method is to express t in partial fractions or otherwise. The otherwise method, actually I don't quite suggest this method because it is super nasty and it requires some other additional knowledges that we won't cover in high school curriculum. So let's see what will happen if we express t in partial fractions. So t let me see, t infinity is equal to 4 plus 6x over 2 minus 5x plus x squared. Yes, plus 2x squared. And we want to express our denominator into the multiplication of two linear factors. -1, -2, 2, 1. So we have 4 plus 6x over 2x minus 1, x minus 2. And we do the partial fraction. A plus x minus 2b. And we have 2x minus 1, x minus 2, a, x minus 2 plus b, 2x minus 1, 2x minus 1. So this gives us by matching all the coefficients on the numerator, we have so a plus 2b is equal to 6, and negative 2a minus b is equal to 4. Now, this is equivalent to a plus 2b equals 6, negative 4a minus 2b equals 8, and we add those two, it gives us negative 3a is equal to 14, and a is equal to negative 14 over 3. Okay, so by substituting a is equal to negative 14 over 3, we have, let me see, 2b equals 14 over 3 plus 6 is equal to 18 over 3. So our b is equal to 1 over 2 times 3 divided by 32 over 3, which is equal to okay, let me see, which is equal to 16 over 3. I believe I'm correct. So our T infinity from here, our T infinity is equal to A is negative 14 over 3, which is 14 over 3 times 1 over 2x. Am I correct? Really? So we check the so we do a little check. I think I made a little mistake on that. 2 times 16 over 3, this equals negative, this equals 3, this is equal to 32, and we have T. So here we have 28 minus 16 over 3, which equals 12 over 3, which is equal to 4. Yes, I'm correct. I am correct. So here we have plus 16 over 3 times 1 over x minus 2. And you may notice that this term is a geometric progression. And in fact, we can make this term into geometric progression as well by simply transfer it into simply transfer it into so negative 8 over 3 times 1 minus x over 2 1 over x minus x over 2. So if we expand those two fractions by geometric progression, we will have 14 over 3 times 1 plus 2x plus 2x squared plus dot 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 all the way to infinity minus 8 over 3 times 1 plus x over 2 plus x over 2 squared plus dot 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 all the way to infinity. So our goal is to find the expression for the sum of first n plus 1 terms of t. So the first n plus 1 terms of t is just 14 over 3 times 1 plus 2x plus dot 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 all the way to 2x to the nth. And for the next term, it's just 8 over 3 1 plus x over 2 plus dot 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 all the way to x over 2 to the n. And next we have 14 over 3, and we use the summation for first n plus 1 terms for geometric progression. We will have 1 minus 2x to the n plus 1 over 1 minus 2x minus 8 over 3 times, so 1 minus x over 2 to the n plus 1 divided by 1 minus x over 2. And this is our ultimate answer for the summation of first n plus 1 terms of t. And this is the end of this video.